Hello friends, welcome to Risingpearl.com. Today we are talking about series 4 where we are learning applications of trigonometry. This is webisode number 3 and friends, today's topic is solving questions and problems that relate to heights and distances. This is part 1. Now we are going to cover this over probably like 2 or 3 parts. Now we have mentioned in the last webisode number 2, that the problems that we see where we can apply trigonometry, they really boil down to heights and distances. And also friends, I would like to just quickly remind you that it was series number 3. This is series 4. But series number 3 is when we started learning about trigonometry. Trigonometry, because it is the first time in this grade that we have learned about the basics of trigonometry. So I hope and I strongly suggest that if you have not taken a look at series 3, please do that first before you come to series 4, because in series 3 we discussed everything about trigonometry, trigonometric ratios of certain important angles, complementary angles, and identities, so on and so forth. So with that said friends, let's take a look at what kind of questions that we may be getting in trigonometry. Now this is a table that we have kind of gone over and over again, just simply because it is so important to make sure that you know these values. These are the 6 trigonometric ratios, right? So we have sine, cos, tan, cosec, sec, and cot. These are the 6 trigonometric ratios, so there are 6 of them. And these are some very important angles or standard angles. So what are they? They are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. The reason it is so important that you know this table, actually you should memorize this table, you should remember this table the way you remember your tables, which is tables from 2 through 20, right? So 2 5 is a 10, 2 6 is a 12, so similar, so on and so forth. These values are absolutely must for you to remember, because when you are going to apply trigonometry, you are going to see questions in which you are expected to know these values. So now one simple way to remember, which we have discussed earlier, is that these highlighted values, that is for the ratio sine, cos, and tan, if you only know sine, cos, and tan for these angles, you can very easily extrapolate cosec, sec, and cot, because cosec is reciprocal of sine, sec is reciprocal of cos, and cot is reciprocal of tan. So if you know these highlighted values, right, at the very minimum, then you can basically easily extrapolate for the other values as well in this table. So that's it. That's it, friends. Let's dive into the first question for trigonometry. How do we apply trigonometry? So the question goes like this. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 45 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 10 meters. Find the height of the tree. Now if you are reading this question, there is a lot of things going on in here. But first what we are going to do, we're going to first draw ourselves a tree. So here I have drawn a straight line and I'm assuming this is the tree. Next I'm going to draw the ground. So the tree is standing on a ground. Now note that here I am assuming the tree is standing upright, straight. This is a very fundamental assumption. I'm not going to assume that the tree is leaning left, leaning right. The tree is standing straight upright, so the tree makes 90-degree angle with the ground. The next is where the question is, which is that the top of the tree. So here I have randomly taken certain height, and basically what has happened is that the wind was blowing from this direction, I'm assuming, and this part of the tree, which is shown in the dotted line, is knocked off and has fallen to the ground. So this is how I have drawn it. Now one very important point to remember, friends, is that whenever we solve questions on applications of trigonometry, we are not drawing the figures or shapes to the scale. So it does not matter that, you know, what are these lengths. So the 45-degree angle. So basically this is the top, this is the whole tree, and let's name the tree. So let's name, so this point, let's call it A. Let's say the base or the bottom of the tree as B. Now this part from where the tree actually got broken, let us say this part is C, and then from here this part fell on the ground here, and this is D, right? So this is our ground, and This was our original tree. The whole AB, this was our tree earlier. This was our whole tree, AB. Now, please note here, friends, that the part where the tree, the top of the tree touches the ground, right? So, the distance between the foot of the tree and where the top touches the ground is 10 meters. So, this length is 10 meters. BD is 10 meters. Now, please note that I am not drawing to scale. This could be any amount. It doesn't matter, right? This is very important to remember. The second thing that you would want to remember is that now you could have argued, or somebody could have argued, that instead of the wind blowing from this side, how about the wind blowing from the other side? And in that case, let's say this was the whole tree and this part, snapped and it actually fell. So instead of the top falling on the right side, the top is now falling on the left side. And this would be equally right as much as this is, because it really does not matter which side the top of the tree is falling. So these are some important things, friends, that these are distinctions. So you don't want to confuse yourself when you're solving these questions. These are important distinctions to be made so that when you approach this type of question, just pick a direction and go with it. And now let's look at what the question is saying. Now the tree breaks due to storm. The bottom bends, the broken part bends, so the top of the tree touches the ground, making an angle 45 degrees. So this angle is 45 degrees. Now again, because we are not drawing to scale, it does not matter what this angle is. It is just important to note that this value is 45 degrees. Now friends, whenever you solve questions related to trigonometry, we are always looking for right triangle. So what do we have here? The triangle BCD is a right triangle because it is clear that the base of the tree is making a 90-degree angle with the ground. So this is 90 degrees. We have a right triangle BCD. So we are looking for a right triangle, number one. Now number two is that if one angle and one side is given, that is, if say one angle plus one side, meaning the length of the side is given, if this is given, we can find out all the sides. How? Simply by applying the trigonometric ratios. So this is very important. So we are looking for a right triangle, and then in that, if one of the angles is given and one side is given, we can find out all the sides. And this is what we are going to use actually in all these questions. So here, we want to find out the height of the tree, right? So height of the tree is AB. So AB, from A to B, is the height of the tree, and AB from the figure we can see it is AC plus BC, right? So it is AC plus BC. Now, how much is BC? So if you look at the right triangle BCD, BC, we know angle D, which is 45 degrees. So how does the side BC relate to angle D? Well, the side BC is right opposite to angle D. So what is the relationship where I can use opposite side and adjacent side? Because for angle D, BD is adjacent side. So opposite side, adjacent side, well, that relationship is tan. So tan D is going to be BC divided by BD. Or we can say, now tan 45 degree, because angle D is 45 degrees. So tan 45 degrees will be equal to BC, which is the value we are trying to find out, by BD, but BD is 10. So this will be 10. Now tan 45, friends, is equal to 1. And that is coming from the table that we looked at earlier. That is why it is so important to know this value. So tan 45 is equal to 1. So from here what we find out is that BC simply by taking the 10 on the other side, is 10 times 1, or it is equal to 10. So we have found out that the length BC is 10. So BC is 10, but we are trying to find out AB. So we have found out BC. What about AC? Now AC, as we can see, is really hanging by itself, not part of the right triangle. But we know that it is the top part of the tree which is broken and has fallen to the ground. That means that this length is actually equal to this length, because it is this part of the tree which has fallen to the ground. So if we somehow can find out CD, then we can find out basically AC. Now, in the right triangle BCD, this side CD is the hypotenuse. It is opposite to the 90 degrees, right? So now what is the relationship that exists between hypotenuse and adjacent side? It is cos. So we can say cos D, or let us say cos 45 degrees, is actually equal to BD, which is 10, divided by CD. Or cos 45 is 1 by square root 2. Again, like the way you need to know tan 45, you need to know the value of cos 45. This is 1 by square root 2 is equal to 10 divided by CD. Or from here we can say that CD is equal to 10 times square root 2. This much meters. So here, friends, so coming back to AB, in the interest of space, let's write it here. So AC is equal to CD. And what is CD? CD is 10 times square root 2. So this is CD. So we write 10 times square root 2 plus, what is BC? BC is 10. So for the interest of the time, I'm not going to further solve it. But friends, this is how many meters or how tall the tree is. Right? So if you can just simply put, like, the value for square root 2 up to 1 or 2 decimal places or 3 decimal places, multiply this and then just add that to 10. This is going to give you the length of the tree. So friends, this is really important from a fundamentals of how do we solve these questions. Right? Let's take a look at one other question to go over these fundamentals one more time. So here the question goes like this. The angle of elevation of the top of a tower from a point on the ground which is 20 meters away from the foot of the tower is 30 degrees. Find the height of the tower. This is really confusing the way the question is written, but let's try to break it down. The angle of elevation of the top of a tower. So there is a tower, right? And the angle of elevation, so looking up to the top of the tower, because we are looking at the top of the tower, from a point on the ground which is 20 meters away from the foot of the tower. So I have a tower, and from there I am standing away from 20 meters. And from that point I am looking at the top of the tower, and the angle of elevation is 30 degrees. Find the height of the tower. So how are we going to solve this? First, we are going to draw ourselves the tower. So let's say straight vertical line, this is the tower. Next, we are going to actually walk away 20 meters from the tower. And then we are going to be looking up to the top of the tower. Again, we discussed when we did the last question, we are not drawing to scale, right? Number one. And number two, it is not given which way are you walking from the tower. So here I have shown that we are walking in this direction. Clearly, you could have drawn the tower like this or any other length, and you could have assumed that instead of walking this way, you are walking that way. The answer would not change. So it does not really matter which way you are walking, as long as you're walking away from the base of the tower or the foot of the tower. That is what is important. So what this is that, so this is our tower. So this is our tower, and so this is the foot of the tower. So let's quickly first name the tower, AB. You don't have to name it AB. You could have named it PQ or XY or anything else, right? So AB. Now we are walking away from the tower. So let's say, so we walk away to a point which is C, right? Now, this is 90 degrees because we will assume that the base of the tower makes 90 degrees with the ground, right? Because this is actually the ground and this is the tower. So the tower is standing straight vertically, that makes 90 degrees with the ground. And now we have walked away. How much have we walked away? We have walked 20 meters away from the foot of the tower. So BC is 20 meters. So let's write this, what we have been given. BC is 20 meters. Now after we have walked 20 meters away, now we look up and the angle of elevation of the top of the tower is 30 degrees. So this angle is 30 degrees. So angle of elevation, we know, we have looked at this in the last webisode. Whenever we are looking up, the angle which is made between the line of sight and the horizontal looking up is angle of elevation, right? So this is 30 degrees. So again, friends, we have a right triangle ABC. We have angle C is equal to 30 degrees, and we know BC is equal to 20 meters, which is same as this. So we have a right triangle and one angle and one side is given. What do we have to find out? We have to find out the height of the tower. That means we have to find out AB. So we know that if we know one angle and any one side, we can find out all the sides. So now let us talk about AB. So in relation to the angle, what is AB? Well, AB is the side which is right opposite to the angle. So this really is the opposite side, right? So, and BC is given. So for this angle, BC is the adjacent side. So what is the relationship between opposite side and adjacent side? It is tan. So tan C is equal to AB divided by BC in our right triangle ABC, right? Now we will just simply put the values. So tan C is nothing but tan C is 30 degrees. 30 degrees. Now we will just put the value. So we will have AB divided by BC is 20. So we write 20 times. Now we have to know the value of tan 30. Like I mentioned again earlier in the table that I had shown, tan 30 is 1 by square root 3. Or AB is equal to, so this goes over here, so it will be 20 times square root 3. Now we would want to rationalize the denominator. It is just a common practice. We don't want to have the denominator as an irrational number. So we can just simply say that AB is equal to 20 divided by square root 3. To make it a rational number, we multiply denominator and numerator by square root 3, so that the denominator becomes 3, which is a real rational number and not an irrational number, and the numerator becomes 20 times square root 3. So this much or this many meters is the height of the tower. Again, friends, so this is how we solve these questions. So whether it is a tower or a building or a mountain or anything else, as long as we have a right triangle, we are looking for a right triangle, we are trying to make sure that one of the angles other than 90 degree, one of the angles is known, and if we know one other side, we can figure out all the other sides. So friends, in the next episode, we are going to take a look at some more questions on applications of trigonometry.